Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's puzzle is called Ninth Wheel by Refrigerator. And here are the rules. Normal Sudoku rules. Place the digits 1 through 9 exactly once in each row, column, and box. We'll get a box here eventually. Black dots. Digits separated by black dots are in a 1 to 2 ratio. So for example, if this was a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio. And these are also known as black crocky dots. And the next rule is called white dots or white crocky dots. And digits separated by white dots, white dogs, oops, a little spelling error there. White dots are consecutive. So for example, if this was a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And then this is the new rule, which I've never seen before. It's called two-entropic line, where any set of 5 sequential cells along the purple, doesn't really look purple to me. It looks like it's like a navy blue or maybe an indigo. It's a little dark for indigo, but any set of 5 sequential cells along the purple entropic line must contain exactly one digit from each of the sets 1, 2, 3, 4, 5, 6, 7, 8, and 9. And hence that the 9 is by itself, so the 9 is the ninth wheel, which is in reference to usually a third wheel. But here it's the ninth wheel because there are already 4 couples, which is 1, 2, 3, 4, 5, 6, 7, 8. But the interesting part is those couples are always separated, right? Because you can only have one out of each of those sets, including, so 1 out of 1, 2, 1 out of 3, 4, 1 out of 5, 6, 1 out of 7, 8, and a 9 have to be in every 5 cells that are in a row on this blue / purple / indigo line. So for example, if you had, this would work if, for example, you had something like this being a 3, this would be an 8, you have a 1, a 5, and a 9. Because you have 1 each from each of the sets, right? The sets are, again, 1, 2, 3, 4, 5, 6, 7, 8, and then 9 is a set by itself. And those are the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. So let's learn how to Sudoku. Okay, so what I like doing in these sequential sets, where you have 5 or 4 or 3 or even 2 of a set in any specific pattern, is to start coloring things randomly. So I'm going to make this blue, yellow, red, green, and pink. And the thing is, you know these are all from different sets because we are required by that on the line, right? So you have to have any 5 sequential cells must have one of each of the sets. Well, what about the next set of 5? Well, we only have yellow, red, green, and pink on those lines in those 4 of those 5 cells. So the last one has to be the same set as the blue one because that's the only one that's left. So this is blue. Same with the next 5. With the next 5, you've lost a yellow, so you need to gain a yellow back, and you always do this for every 5th set, right? So for this works for a lot of different rule set. Like the typical entropic line is you have 3 sets that you have to have 1 out of for every 3 cells on a line. This is just different because it's 5 sets, and you have to have it 1 from each set for every 5 cells on the line. So again, this would have to be the 5th set that we lose, which would be red. This would be green. This would be pink. And then we're back again to blue, right? Because we have blue, yellow, red, green, pink. We've lost the blue again, so we need another blue here. So this is blue, this is yellow, this is red, green, and then we can keep doing this along the line. Green, pink. Again, we've lost the blue out of yellow, green, red, and pink, so this must be blue, which makes this green. Sorry, no, not green. Green, this must be yellow. This is red. This is green, pink. This is blue. Then we have yellow, red, green, pink. This is blue, yellow, red, green, pink. This is blue again. Blue, yellow, red, green, and pink. So the interesting thing is, these have to be the blues in each cell. These cells have to be blue. Well, we know this blue cannot be the same as that one, and it cannot be the same as this one either. And there's only 2 cells in each blue cell. Sorry, 2 digits in each set that's in blue, right? And on top of that, this blue set has to be in a 1-to-2 ratio. Well, the only set that contains a 1-to-2 ratio between the digits are 1 and 2, right? So this has to then be both blue, which makes this 1 and 2. This must be 1 or 2, and it's in between 2 unique digits. Also, we have 2 yellows, 2 reds, 2 greens, and we need 2 blues in this box. So this has to be a blue. This blue is in a 1-to-2 ratio with a non-blue. So it must be specifically 2 and 4, right? Because we know one of them is 1 or 2, but if it's with another one can only be double in a 1-to-2 ratio with 2. So this cannot be 2. This can't be 1 here, because this is in 1-to-2 ratio with another digit and with yellow. So this must be 2, which makes this a 4 and makes this a 1. Well, the yellows now are the 3-4 set, so this must be a 3. 3 is next to 2, so this must be 2. 3 is consecutive with 2, I should say, so therefore that's a 2, and this is a 1, which forces this to be 1. 1 is only in a 1-to-2 ratio with 2, so this is 2 again, and this is blue. This is blue. So we now have both blues in this box. We have both blues in this row. Let's see. 3 and 4 has to be in a 1-to-2 ratio here. And this has to be 3 or 4. This is 3 or 4. 3 or 4 is only consecutive with 2 out of the blue. So this must be 2, this must be 3, this has to be 4, and this must be an 8. Well, we don't know which set this is part of. It cannot be yellow. It cannot be red, because both reds are here in column 2. It could be either green or it's pink. We're not sure which. So this is green or pink as an 8. We know red cannot contain 8 and cannot be 1 or 2 or 3 or 4. So the red has to be 5 or 6. And this 5 or 6 is in a 1-to-2 ratio with something. Well, the only digit that can be in a 1-to-2 ratio out of 5 or 6 is 6. So this is 6, this is 5, this is 6. This must be 3 and must be a yellow. So this must be 4. Oops, 4. This is the only other blue in this box, so this must be a 2. Therefore, this can't be 4 and 2. This has to be an 8 here, which is, again, green or pink. We're not sure which one. Therefore, this is a 6 here as the other red. This has to be 5 or 6, which is next to 4 or 7, but we're not sure which one's which. This is 5 or 6, and this is 5 or 6. This yellow is 3 or 4. This green is in the 1-to-2 ratio. Well, we've already accounted for 1, 2, 3, 4, and 6. So the last one must be 8. So this must be green. So all the greens, actually we sort of knew that actually because we had 2 greens here in the same box. And therefore it probably had to be 7 and 8. And therefore the pink is the 9. So all the pinks are 9. 8 is in a 1 to 2 ratio with a 4, which is yellow. So this is the last 4. This is not an 8, so this must be a 7. Well, this 7 means this can't be 7, so this must be a 4, which is a yellow. And therefore this must be 5 to be consecutive with it. This has to be a 7, and 7's only consecutive with 6 and 8. Well, we're not sure which one it is. This has to be 3 or 4. This has to be a 1 because it's the last blue. This has to be a 1 because that's the only digit remaining. So this is a blue. This green is a 7 or 8, and it cannot be consecutive with 9. So this can't be 8, so therefore this is 7. Actually could be that this is 7, and this is 8. So this could be 7, 8, or this could be 6, 7 here. We're not sure which. This is 1 or 2. These have to be consecutive. This can't be 1, 8, or 9. So it's 2, 3, 4, 5, or 7. If this is 2, this would have to be 3, but it can't be. So this can't be 2. If this is 3, it cannot be with 4. It could be with 2, though. So this could be 3 and 2 this way. If this is 4, it cannot be 3 here because this can't be 3 or 4. So this could be 4 and 5. If this is 5, well, this can't be 4. This is 4 and this is 5. If this is 5, this would have to be 5 or 4 or 6, but it can't be either. So this cannot be 5. And if this is 7, it has to be with 6 or 8, but it can't be 6. So it would have to be 8 if that's a possibility. Okay, this has to be a 7 because it's the last remaining green cell in row 5. And now we have 1 and 6 remaining. Well, this can't be 1, so this must be 6, which makes this a 1. This is a blue, and this is a red. This is a green again. We don't know what this is. Where is the 7, actually? In column 6. Cannot be any of these because of the 7s in the boxes. Can't be here, so this must be a 7, which makes this an 8. So this is the last 7 here. This is 8. How many 8s do we have? We don't have that many 8s. These digits are consecutive. It cannot contain a 1 because there's a 1 in each column. It could be 2, 3 if this is 2 and this is 3. It could be 3, 4 with either side being 3 or 4. It could be 4, 5 with both sides being 4, 5. It cannot be 5, 6 because that would eliminate all possibilities for that cell. It cannot be 6, 7 or 7, 8 because of the 7 in the row. And it can't be 8, 9 because we already have a 9 in that column. Actually, let's figure out where the 9s can be. 9s cannot be here or here in the middle box, so it must be here. So this is a 9 and is the pink. The last pink we know because we have 8 9s already, and the last one has to be here. So this is a 9. 5 cannot be here. So 5 has to be one of these 2 cells. We also have 3 and 7. This can't be 7 or 5, so this has to be a 3, which is the last yellow. This is 5 or 7. This is 5 or 7. The remaining digits here are 5 and 6, and this can't be 5, so this must be 6, which makes that a 5. These are both red. This can no longer be 5 here. The remaining digits here are 1 and 8, and this can't be 1, so this must be an 8, which makes this a 1. This is a blue. This is the green. Let's see, we have 9s, we have 8s. Where is the 8 in row 3? It cannot be here because it's not consecutive. It cannot be consecutive with any other digit because 7 and 9 are taken. So it must be here. So this is an 8, which makes this a green. This can't be 8, so this is 7. This is 7, which makes that an 8. We have 7 8s, so we're still pretty, we don't know where things are. Let's look at everything in column 1. What are the possibilities? It's 3 and 5. Either of them can be 3 or 5. We don't know which. We do have in this upper left box a 3 4 5 triplet though, which eliminates 3 4 and 5 from the rest of the box. Therefore, this must be a 6 and is a red. Okay. This cannot be 4. The rest of this is 3 5 and 7, which seems fine. Let's see. Where is the 6 in row? Well, where is the 6 in row 3? Cannot be here because it can't be consecutive with... This can't be 6, and if this were 6, it would have to be consecutive with 5, and that would break that cell. So it has to be one of these two cells, which means the 6 in row 1 has to be one of these two cells. Oh, this can't be 6 because of a 6 already here. So we know this has to be a 6 here. That's the only possibility. Does that tell us anything else? Not really. Where is the 4 in row 3? Can't be any of these cells because this is a 4, so it must be one of these two. Well, 4 is only consecutive with 3 or 5, so this cannot be 2. We know one of them's a 4. Where is the 2 in row 3? Can't be here anymore, and it can't be here because of this 2, so this must be a 2 here. And as a blue, this has to be 3 or 5. We're not sure which. Okay, where's a 2 in... well, this can't be 2 anymore because of this 2. So this can't be 3 because 3 required a 2 here because out of the digits, it could not contain a 4 or a 2 now, so this can't be 3. This is 4, 7 with 5 or 8 here. This is 2. This is 2. So where is the last 2 in column 8? It has to be here. So this is 2. This has to be a 4 then. So this is blue. This is a yellow. Where's the 1? We actually have a whole bunch of... And this actually can't be 4. Let's just go that way. That's easier. This has to be a 7 then, which forces this to be 8. Which means this can't be 7. We now have a 3, 5, 3, 5 pair in row 4, which eliminates 3 and 4 in the rest of the row. This must be a 4. The remaining digits are 1 and 2, and this can't be 1 here, so this must be a 2, which makes this a 1. We have all the 1s except for 1 now. We have 8 1s, so the last one we know where it is. It has to be here, and this is blue. The 2s, we actually have 8 2s, I think, too. Yep, we have 8 2s. And we know where the last 2 has to be. It has to be here. So this is a 2. This is 3 or 5, but it cannot be 5. So it must be a 3 here. So this is 3, which makes this a 5. This 3 is a yellow. The 5 is a red. That makes this having to be a yellow, which makes this having to be red, and this is a green, and 7. This is now a 4, because that's the only possibility. And this must be a 3, because it can't be 4 or 5 anymore. So this is 3, which makes this 5. This is a 4. This is a 3. This is a 5, and it's red. This can't be 5 anymore, so this must be 7, which makes this a 5. And this is red. This is yellow. This remaining digit is now a 1. Oh, wait. Can't be 1. It's a yellow. No, green. It's a no, this is green. These are both greens. What is it? Red. Apologies. This is red. Wait, no, this is red. Oh, no. I got started coloring wrong. This is green. Okay. This is green. This is red. This has to be yellow. And these are green. Okay, there we go. So this is a red. The remaining digits here have to be yellow, but this has to be the yellow. And this has to be... These both are red. And this is a green. So that, and these are green, but this one has to be green, and this has to be red. Well, this red cannot be a 5, so it's a 6, which makes that a 5. This must be a 6. This is a 3, because it's the only digit remaining. This is a 7, because it can't be 8. This is 3, because it can't be 4 here. This is a 5. This has to be an 8. And that's how you solve it. Aside from my coloring shenanigans, yeah, I did. Yeah, that's fairly simple. And you can apply this to like all the different lines where you have consecutive sets, or you have to have one of multiple sets in a consecutive sequence, right? So it's very useful, that technique, to be able to figure out where things can be, right? So like I found out these blues had to be in a 1-to-2 ratio. There, and the only set that has a 1-to-2 ratio is 1 and 2. So anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.